Hello and welcome back to Cracking the Cryptic. As we continue to strive for 300,000 subscribers, we're getting very close now. If by any chance you haven't already subscribed, please do. Now, this puzzle, Simon sent it to me when he was on the phone to me, and I think he told me it was by GlumHippo, but I had a quick look in our emails and around places I know, and I couldn't prove that. So there is a chance you're seeing a card about now saying, no, it's not by GlumHippo. But if it is, that's our friend Philip Bloomer, who does some quality puzzles, as you'll know if you've followed the channel. He also very, very politely requested us to credit his artist friend Miriam Martincic, who created the graphic of the GlumHippo that you will have seen in the thumbnail. So happy to do that as well. Now, this is just a killer Sudoku, so do have a go on the link below the video. The rules of killer Sudoku are obviously that the digits in each cage sum to the number in the corner. Now, probably importantly in this puzzle, they cannot contain repeats, and I'll tell you why as we get underway. And obviously normal Sudoku rules, 1 to 9 in every row, column and 3 by 3 box apply as well. Do have a go on the link below the video. I don't believe it's very easy, but I do believe it's going to be good fun. So that's worth a try, I think. Now, with which I'm going to say, let's get cracking and make my effort. Now, the reason I said it's probably going to matter hard that there's no repeats in this one is there are some enormous cages. And I noticed this immediately on loading the puzzle. You've got, I'm going to colour these. Let's see what happens. There are 8-digit cages all over this grid, I think. I think every one of these that I'm doing so far is an 8-digit cage. Let's make that one blue. And this one as well. Yes, every single one of these 6 cages is an 8-digit cage. Oh, there's another one. Hang on. 1, 2, 3, 4. No, yeah, there are 6. I was right about that, but not right that I'd coloured them all. That's the 6th. So there we go. 6 different 8-digit cages. Now, the thing we're going to need to absolutely be aware of in this puzzle is that 45 is the sum of the numbers 1 to 9. I hope you didn't get caught in the blast radius of that Cracking the Cryptic knowledge bomb. But that's important because what you know about each cage is that whatever the difference is between 45 and the cage total, that number is the one digit that is not in the cage. So, oh yeah, look at this 41 cage. This is beautiful for the 41 cage. So you take 41 from 45, there is no 4 in the red cage. And then as soon as you think of the question, where does 4 go in box 8? You know exactly where it goes. It goes here, because that is the only non-red, non-filled cell in box 8. And you also know, because of the 41 cage, it contains every digit apart from 4. That is the whole point of this. And therefore, where do 9 and 2 go? Well, they must be a sort of weird pair at the corners. I mean, both in row 8, but at the ends of where it gets to in row 8. Well, and then what? You know that this yellow cage doesn't have a 3, so 3 is confined to one of those 2 cells. The green cage doesn't have a 9, which is not as helpful. The purple cage doesn't have a 6, but that still leaves 3 cells here. The orange cage doesn't have a 2. Ooh, you can nearly restrict 2 in column 7. That cell and that cell are the only ones that aren't orange or in the same row as that too. I'm tempted to pencil mark them, but I might get confused if I do pencil marks that stray outside as individual boxes. If I do corner marks, anyway. And the blue doesn't have an 8. Ah, no. Okay, I thought maybe I could exclude 8 from there as well, but I can't. Okay, so only the red cage was really helpful there. So what else can we do? Look at this 17 cage. Now, you wouldn't normally think in a puzzle with loads of 8-cell cages about which you know their constituents that a little 17 cage was going to be any help. But this one, well, the point is you know there's not a 2 in it, because those 2s can not be, those 2s prevent these cells having a 2, because there must be a 2 in one of them in row 8. That one says those 2 can't have a 2. Now, there are still a number of combinations that work in a 17 cage, but they must involve a 1. Because 3, 4, 5, 6, the first possibility that doesn't involve 1 or 2, adds up to too many. That's 18. So there must be a 1 in the 17 cage if there can't be a 2. That 1 tells us it's not in those digits, so it's in one of those. And now where's the 1 in row 7? It's got to be here, back in the 41 cage. Okay, well, I have a feeling that as we go along, we're not going to pick up insights much more. Sorry, I'm going to just stop my phone pinging with WhatsApp messages. My apologies for that. We're probably not going to pick up more than one thing at a time. I was wondering what else has to be in the 17 cage. So the possibilities now are 1, 3, 4, 9, and 4 can get into it easily. There's too many possibilities. There's going to be 1, 3, 5, 8, 1, 3, not 1, 3, 6, 7 because of that 6. Okay, 1, 3, 4, 9, 3, 5, 8, 4, 5, 7. Actually, only those. 3, 4, 9, 3, 5, 8, and 4, 5, 7. That's not quite narrow enough to really know what's going on. If it's not 1, 3, 4, 9, well, where would 9? I suppose 9 could be there and therefore 9 in one of those cells. Oh, that's not quite as helpful as I was hoping. Right, let's try and focus on something else then. What else can we find? It's tricky. It is tricky because there's just so little actual information anywhere here. I don't quite know what we ought to be looking at next. Quite pleased to have spotted that about the 17 cage, frankly, but we cannot rest on those laurels. Right, let's see. Where is the 7 in the 39 cage? It must have a 7, so it must be in one of those 2 cells. That means 7 is in one of these 2, but that's not very conclusive. I suppose it means the 7 in the 43 cage is in one of those 4. Yeah, I mean, this may be the kind of way to look at it, is every time you consider a cage, you have to consider where all the numbers that you know are in it are going to be. Right, where's the 1 in the 42 cage? Well, this 1 is seeing lots of the cells in that cage, so 1 is now confined to those 2. Ah! Okay, where's the 1 in the 36 cage? No, okay, that's not as helpful. It could be in any of those 3. Where's the 1 in box 1? It's in one of those 3 cells. Now, the key point here is with 1 in one of those 2 and 1 there, the 15 doesn't have a 1, and therefore it must be made up of 2, 3, 4, 5. No, 2, 3, 4, 6. There's only one possibility without a 1. It's 2, 3, 4, 6. So it's got to be that. So let's mark them in. These 2 can't be 4s. And it's quite surprising that 2 little 4-digit cages are actually any kind of help here. Now, what else can we do here? The 39 cage doesn't have a 6. Ah, this digit this cell sees all of the numbers in the 15 cage. So it can't be 2, 3, 4, 6, or 1 or 7. So it's 5, 8, or 9. I don't know if that's much gained. It's just starting to wonder about where the 2 is in the 42 cage. In the yellow. It's got to be in one of those cells. And there's also got to be a 2 in one of these cells in the 15 cage. So where's the 2 in column 3? Unfortunately, it doesn't actually prove much. Where's the 2 in the purple cage, in the 39 cage? It's not in any of those 3 cells because of that 2. Therefore, it's in one of these, and they all see that cell, which can't be a 2. I mean, literally, this could come down to just picking off candidates one by one, which is going to be a bit sad if that's the case. But let's keep going and see if anything pops loose. Right, where's the 4 in the purple as well? It does have a 4. Again, that's not in those 3. And again, it's in these ones. So this, again, can't be a 4 because it sees all of those. I wish I could pull off that trick one more time. Maybe I can. Can I? The 39 cage doesn't have a 6. No, that's not so helpful. 6, well, it could be in any of those 3 cells in box 2. And 2 of them would be absolutely fabulous. They would rule it out of those. But it could still be there. In fact, where is 6 in the orange? One of those 3 cells, which are quite limited, but not enough to actually put anything in. Right, what question should I be asking? This is absolutely the problem, is you just can't see immediately what is helpful to know. Ones. Well, one's more useful than I was allowing. Don't think so where's the 1 in the blue? Yes, this one says it can't be in any of those cells. So it's in one of these 4. Now, I'm going to pencil mark them. They're all in the same blue area, so hopefully I won't suddenly think that it's confined to those 2 cells. But the fact that in row 6 the 1 is somewhere in the blue means it's not there, and therefore we can actually place a 1 in the grid there. Which is the most minimal gain. I seriously think this is going to be 1 cell at a time, and I'm sorry, that means the video is going to take ages, but I just don't know a way of going at this faster. Right, but let's keep concentrating. Right, 4 and 6. They're now looking at those 3 cells, so within the yellow, they have to be confined down here. That's getting quite interesting. Because one of them, at least, is going to be in columns 1 or 2, along with a 4 and 6 in that area. Ooh, that's nearly telling, but not quite. Oh, this is a 2, 3, 6 pair. I decided 4 can't be in those. Yes, because 4's in the purple somewhere there. So in fact, we can place the 4 in the 15. Okay, sorry, that was more useful. So 4's not there. Oh no, but it could be in row 1 in the purple. 4, 1. Okay, where's the 4 in the green? Is there a 4? Yeah, there is a 4 in the green, and it's not in any of those cells or that one. So we can place the 4 in the green as well. Okay. The 4 in column 7 is in one of those 2. Which hang on, is that really still, oh yeah, it might be not in the purple there. That's the only way it could be in the purple there, but that would work fine. If it was there, it's in one of those two along with the 7. Ah, no, perfect. Where is 4 in the orange? It's not here because of that one. It's not here because of that one. It's not anywhere there because of that one. So 4 is here in the orange. So 4 is with the 7 in one of those two. And that means that 1 cannot be here because they're a 7-4 pair, and we can place 1 there. 1, 2, 3, 6, 4, 7. That's not 1. These other 2 cells in box 1 are 5, 8, or 9. Which isn't quite as helpful as I was hoping. Right, what about the purple? Yes, 1, 4, 7. It doesn't have a 6. But it does have 2, 3, 5, 8, and 9 in a cross shape. It doesn't have 2 in column 5. Now, the point about putting 2, 3, 5, 8, 9 in 7, 4 there, these two are 1 and 6. And look, we actually know which way round they are. So this cell was a peculiar naked single once we forced 2, 3, 5, 8, 9 into the cross shape. Now, 6 there, brilliant. This pair comes down to a 2, 3 pair. We can place 6 there. And not here. So in fact 4 and 6 are now confined to these 3 cells in the 42 cage, which doesn't have a 3. Oh, I don't know quite if we've learned anything else. Not, oh, well, okay, no, I was going to say it has an effect on the 17 cage, but I can't see that it does. I think I was getting ahead of myself. Can we finish off 4s? Yes, we can actually, because the 4 in the blue's already done. 4 there, 4 there, 4 can't be in the blue, that must be a 4. Oh, and that's in the 9 cage. Let's just finish off the 4s because we can. That's done them all. Come back to the 9 cage where we can now put in a 5. Thank you, 2-digit cage. You've been very helpful. And 4 and this 4 and 5 see every cell in the 28 cage. Now, does that limit that? 9, 8, 7, 3, 1. 9, 8, 6, 3, 2. Yeah, I think there's got to be 2 cells from below 4. You can't have 6, 7, 8, and 9 in it. That would be 30. So you've got to have either... Oh, hang on. Look, I think I can rule a 1 out of the 28 cage. Where does 1 go in the 43 cage? Oh no, it doesn't. It's not going to rule it out. No, it is. It is going to rule it out. Yes, 1 in the 43 cage has to be in one of those cells or that one. Now, I don't know which one it is, and if I marked them, that would probably confuse me. But, oh no, I was thinking there has to be a 1 in one of these two, but this is exactly the problem I was worrying about in pencil marking these ones. I'm getting confused and thinking that's a pair, and it's not. Right, 1 in the central box has to be in one of those two. Yeah, but I mean, it's still right that there's a 1 in one of those 3 cells. But it all depends here on where 1 is in the 37. Whether it's in box 5 there or box 6 in one of those two. If I could have confined 1 to one of those 2 cells, and to one of those 3, then I'd know the 28 cage couldn't have a 1, but I don't think I have the wherewithal to know that yet. That's irritating. Maybe I know the opposite, that there must be a 1 in it. No, I don't think I do. Just talking nonsense. Sorry. Right, that's not a 3. This is 6, no, it's 5, 6, 7, 8 or 9. Yeah, I mean, I think the conclusion I'm coming to is this 28 cage has 3 big numbers from 9, 8, 7 and 6 and 2 small from 1, 2 and 3. Now, just trying to do the maths. 9, 8, 7, 3, 1 works, and 9, 8, 6, 3, 2. Now, there's no 2, 1 doesn't work. That would leave too many. So those are how to do it. So it's got 9, 8 and 3 in it for sure, which is quite a surprising conclusion. Doesn't quite butter my parsnips, unfortunately. Oh, right. Let's think again then. What can we do to find some progress? 6. Ruled out of those. That 6 rules. Isn't 6 is correctly confined to one of those? Yes. So that's not a 6. So 6 is in one of those 2 cells. Probably not going to help us at all, but it is nonetheless true. Now, this 17 cage hasn't got any better yet. I just feel I'm very close up here. 6, 6. Right, where's the 6 in the 43 cage? Oh, that's the question. Can't be in any of those cells because of that 6. And that 6 has ruled it out of there. And there is a 6 in the 43 cage. It's there. Now there's a 6 in the 28 cage. In fact, it's there. They've got four 6s looking up at that box, so it has to be there. So now we know it's 9, 8, 6, which makes 23, and 3 and 2. Right, let's take out all the pencil marks and everything and write in again 2, 3, 8, 9 as a set. Now that means 1 and 7 feature down here. So the 1 has to be in this cell. One of these is a 7. Now we have to make up 12 more in the 17 cage without using 7, 5 and without using 4, 8. So that's the 3, 9 pair. And in fact, 9 can't be in one of those two, in row 8 there, because it's already been used up by the 2, 9 pair. So 3, 9, suddenly we've got a bit of traction. What a brilliant puzzle to mete out its sweeties so gently, one at a time. Right, 5 has to be there. This is a 7, 8 pair now. That means these aren't 8. The 8 in the cage is here. 4, 8, 6, 5, 3, 9. That is a naked single 2. I love it when there's suddenly a naked single. That makes this a 2. 6, 3, 9, 2, 4. That is 5 or 8. So the only place for 3 in the top row now. In fact, yes, look, we've got a 2, 3 pair looking at that. The only place for 3 in the top row is here. So we can take 3 out of all those possibilities. We can take 9 out of that one and that one, which become a 5, 8 pair. 7 is here. These are from 1, 5, 8. That one is a naked single. That's a 1. This is part of the 5, 8 pair in the box. We've got 1, 3, 9 to put in those cells, and clearly 1 can't be there because we've already got a 1 in the cage. 3, 9 there. This is a 7. Suddenly this is all coming together. Right, the blue cage doesn't have an 8 because it's 37. 5, 1, 7, 4. This lot are 2, 3, 6, 9. So they don't include the 1. We can put the 1 in here. 6 is in one of those 2 cells. 9 in one of those 3. 2 and 3 can't be in the middle column. Then 8 in the box must be here. This is a 5, 7 pair which can be filled in because of that 7. These are from 3, 6, 9, but in this 36 green cage there is no 9. So the 9 in the row is there. This is a 3, 6 pair. Don't know the order. 6s are still in an X-wing. But 3, 6, 1, 4, not using a 9. 5, 8, 2, 7 are in this lot. Let's get rid of that 3 pencil mark. The 3 is going to be there. Right, that's 2 or 7. This is 2, 5 or 8, and this is 2, 8 or 7. So 2, 5, 8, 7 are in those. That means this is a 4. This is 3 or 6. 4, 3, 6, 1. Right, this 42 cage doesn't have... Oh, look, 3 or 6 there. I've already got 3 in the cage, in the box. Perfect. That's not a 6 anymore. Actually, all the 6s? No, they're not all done. Still got 1 pair left there. That can't be a 3. So that is 2, 7 or 9. Oh, that 3 is looking at the 2, 3 pair. That can't be an 8 because of the 8 we placed in the center. So we can take 8 out of there. We've got a 2, 7 pair. Yeah, they can't be 5. The 5 is there. These can't have a 5 in anymore. They're a 2, 8, 9 triple. That sorts out the 5, 8. Those can't be 8. Pencil marks are really helping here. So I'm sure I've missed 1 or 2 that would have helped more as we've gone along, but the ones I have seen have been very helpful. That is 2 or 8. So I've got a useless chocolate teapot triple there. 6, 5, 7 or 8. Oh, it's not quite giving up this puzzle. Oh look, 8 there. That's also fixing this as a 9. That makes that 6. The whole central row is suddenly done. That and all the 6s. These can't be 9. 4, 6, 7, 1. 5 and 8 to place in row 8. I don't think I can do them yet. Right, the 42 cage doesn't have a 3 in it, and we've placed 1, 4 and 6. 7 can't be in those cells because of that 7, so the 7 must be here. Yeah, that seems solid. 2, 9 there. Oh, that one can't be 9 and this one can't be 6. There are 2, 3 pair. 8 and 9 to place here. Still don't know that. That is 5. No, it could be 3. 5, 4, 1, 6, 7, 2. I'm probably missing all the pencil marks now, but never mind. We are closing in on a finish. That is 5 or 8. There's nothing else it can be. 7, 3, 6, 1, 4 in the column, 2, 9 in the row. That gives us a 5, 8 pair in the box. So we can finish off the rest of the yellow cage, which is getting the rest of columns 1 and 2 done. Now that's 7. Yep, that's sorted out this 8, 7 pair. That can still be 5 or 8. We're nearly done here. 3, 5 and 8 to go. And that can be any of them. Okay, what have I missed here? I've missed something. Yes, 5 there. That's resolved it all, hasn't it? 8, 5, 8 there. 2 and 8. 2 more pairs to go. 2 and 3 here. 3 and 5 at the bottom. So that is the solution to GlumHippo's excellent killer Sudoku. Really interesting puzzle. I mean, we've been solving quite a lot of partial killer Sudokus lately because of the puzzles sent to us in the app, and there are so many brilliant ideas that people are coming up with. This is just another one of them. Really looking forward to that app coming out. I think you'll see some special efforts, especially if you like something like this. So thank you very much, as always, for watching. As I've mentioned, do subscribe, have a look at Patreon. There's some great stuff on there lately, especially Jurko van Veenendaal's Puzzle Hunt. And see you soon on Cracking the Cryptic. Bye for now.